Welcome everybody. This is the first talk in the second session here of iRODS UGM 2020. And this is Justin James from the iRODS Consortium. He's going to talk about the work he's been doing with the S3 plugin and direct streaming. Go for it, Justin.
Okay. So my talk today is about the new streaming version of the S3 plugin. I'll just go ahead to the next slide. So last year we enhanced the S3 plugin so that it could be used in standalone mode without a compound and cache resource. This version used S3FS to implement the S3 calls, but still had a cache file at the OS level. The presence of the cache file limited performance since all objects had to be written to disk and then flushed back to S3 for each read and write. This limitation is most evident when the S3 backend is faster than the local disk. Another limitation of the existing S3 plugin is that it does not support dstream because of the multi-process nature of dstream. So dstream will stream things all in different processes rather than different threads. And the enhancement we did last year did not support multiple processes. So we've now migrated to a streaming version of the S3 plugin, which in most normal cases will not require a cached file. Data will be streamed directly to S3 and from S3 as it is received in the plugin. So at the bottom here, there's kind of like a history of the S3 plugin. The first version required a compound resource with a cache and archive. Then we went to the quote unquote cacherless last year, and this year we're going directly to streaming. Okay. All right, there we go. So to do this, we extended the iRODS experimental IO transport class to implement the connections to S3. So the new class that derives from the transport class is called S3 transport, and it provides all the functionality that we need to talk to S3. So for any normal get or put, no cache file will be used. And when the iRODS S3 plugin gets a request for a read, for example, it will go directly to S3 and stream the data from S3 back. When the plugin gets a write request, if the file is large enough to do a parallel transfer, then it will begin streaming. It'll do start a multi-part upload. Then each thread will stream data for its part directly to S3. So for files less than 32 megabytes, iRODS doesn't do a parallel transfer, so we'll just do a normal upload to S3, so that one thread will do the upload. For larger files, there's a one-to-one mapping between the parallel transfer thread and the S3 part. Okay, so one last note, a cache file is still used in some scenarios. These are cases where random access reads and writes are likely to be done. In that case, we don't really have a choice but to use a cache file. So to do all of this, we migrated from the S3FS libraries to libs3. So now we're using the same libraries for both the older archive version of the plugin and the new version. So S3FS is no longer being used and everything is using libs3. Lastly, this new version of the plugin is proving ground for some other libraries. Some of them Corey has talked about earlier. We've added to the iRODS code base. To mention three of them is the circular buffer, size limited circular buffer, which we were using, and I'll go into more detail about that later. dstream and the transport objects, and also this uses the shared memory objects, which is in the iRODS core code. Okay, the next slide, when it comes up, we'll go into the detail of the parallel put. Basically, when we detect that a full file is uploaded, we detect that based on the open flags that are used when the object is opened. If we know that we're doing a full parallel put, the first thread to receive the put will call create multi-part upload. Each thread will then create its own DStream and S3 transport objects, and the writes are first written to a circular buffer, and then each transport object, so each thread has their own transport object. Each transport object starts as another thread to read from the circular buffer and stream to S3. So here's a diagram of sort of what we're doing. It's kind of a simplified diagram, but just to give you an idea of how this works. So, so we, first on the open mode, we detect that this is a full file upload based on the open flags. If we know that we're doing the full parallel put, the first thread to receive the put will call the create multi-part upload, and as you see, first it'll create the DStream and S3 transport object. The first S3 transport object will call create multi-part upload. Then all the other threads, once they get a write operation, they will create their own DStream and S3 transport objects. So all of these writes, again, are written to the circular buffer, and a new thread is spawned for each thread to read that circular buffer and stream to S3. Then once we get the last close operation, the transport object will call complete multi-part upload. So a little bit about the circular buffer. The idea behind the circular buffer is that we limit the amount of memory that may be used. We don't want to, as we're getting read requests, we don't want to fill up your local memory. So we limit the amount of memory that may be used. So once that circular buffer is full, then once the circular buffer is full, any additional write requests will block until there's room in the circular buffer, so that we can limit the amount of memory that's being used. Each thread has its own circular buffer, and the circular buffer is sized in blocks and not bytes. The block size is equal to the size of the buffer used by iRODS. So the maximum number of bytes in memory is the number of transfer threads. For large files, that's usually 16 in iRODS, times the iRODS buffer size times the number of entries that you've set in the circular buffer. This is configured with the S3 circular buffer size parameter in the context string of the S3 resource. And sorry, I'm waiting for my slide to update. Okay, so parallel gets are simpler than puts because S3 allows random access reading from the objects. The request for bytes from iRODS can be translated directly to a GET request in S3. So all we have to do is kind of forward the request in iRODS to S3. Just like the put case, each thread will create the DStream and S3 transport objects to handle the transfer of data. These read operations are all synchronous as well. So when a read request comes in, it forwards it to the S3 transport object and waits until the data has been returned from S3 before it returns back. And here's the kind of diagram of how this works. So each thread creates the S3 transport object, and reads are simply forwarded to the S3 transport object. Okay, finally, there are cases where cache file is necessary. if the object is open in both read and write mode, or if the object is opened in write-only mode, but the object exists and is not being truncated. Those are scenarios where we can't just stream directly to S3 or from S3. We have to use a cache file. So in these cases, when the when the first S3 transfer object is created, the file is downloaded to a local cache file. Then after that, all reads and writes are performed directly against the cache file. And then, excuse me. And then on the last close, this cache file is flushed to S3. So here's kind of a diagram of what happens on open. So when the iRODS thread gets an open, it creates and opens the dstream object. And that triggers, the object knows that it needs to use a cache file in this scenario by the open modes. So it goes out and spawns in threads to stream the object to a cache file. And then once it's streamed, all the objects have been streamed, the threads are deleted, and then the S3 transport object returns back to iRODS. And then once the opens happened and you get some read and write requests, everything is either read or written directly to the cache file via the S3 transport object. So if you notice, there are no lines to the S3 at this point because all these operations are done directly against the cache file. Finally, on close, we call close on the D stream, and this would be the last thread that closes. The D stream will call a create multiple part upload. It'll spawn a bunch of threads if necessary, and read from the cache file and upload to S3. And once all that's done, it will do a complete multi-part upload and then return back to iRODS. Okay, so the performance of this, we wanted to get an idea of how we're doing performance-wise. We wanted to make a comparison between the new streaming version of the S3 resource and the existing cacherless S3 resource, which used the S3FS libraries. And third, as a comparison, we use the Amazon AWS CLI tool. So that we have an apples to apples comparison, since iRODS generally uses 16 threads to transfer large files, I set the maximum number of threads for the S3 API, the Amazon S3 API to 16 threads. And finally, the tests were run against a local MinIO server, which is backed by an SSD drive. This was to simulate the case where the network throughput and latency is not the bottleneck, so that we could compare the performance improvement by not using a cache file. Each upload and download was performed 6 times, and we used the median value in the graphs that you'll see later. Also, these same tests were performed against the Amazon S3 backend. The relative performance among the 3 options was the same. The times were longer because this was going over the internet. And I'm waiting for the next slide. Okay, so for download performance, the one in yellow is the new plugin. So if you see it, the times the performance is better with the new one than either with the existing plugin, the non-streaming version of the plugin, and better than the AWS CLI API. But all of these were mostly linear through the range of file sizes that were tested. And upload when it comes up. Okay, so the upload performance, again, the streaming version of the plugin was faster than either the AWS CLI or the S3 plugin without streaming. And another good thing is, if you remember my talk last year, that nonlinearity you see in the blue line was a little bit of concern. We were going to look into that, but with this new version, we don't have that linearity. So as the file sizes grow, the times basically are just linear. Okay, so the next steps. We're almost complete with development. Just some final implementation details need to be added. There is one bug that needs to be fixed, and that is that right now files between 32 megabytes and 80 megabytes are failing due to the S3 limitation that each part must be at least 5 megabytes in size. If you remember me saying earlier, there's a one-to-one mapping between the iRODS threads and the parts in S3 when you're doing an upload. Unfortunately, iRODS, once you get to 32 megabytes, by default, iRODS will start doing a parallel transfer, and it would use 16 threads by default, and that doesn't give you 5 megabytes size for each part, and so S3 would reject. At least Amazon S3 will reject that, saying the part size is too small. A workaround to that would be to set the transfer buffer size for parallel transfer in megabytes. That's in the Etsy iRODS server config.json. That workaround does work. I tested it out. If I set it to something like 10, then the parallel uploads would again work because iRODS wouldn't use as many threads. But that is not the final solution. We'll fix this in the code so that you will not have to change the default configuration to get these files to upload properly. Lastly, the resource op read directory operation has not been implemented yet. It was implemented in the older version, but that was using S3FS. So we just need to implement this using libs3. And this particular operation gets called like when you do a recursive register on the file system or on the S3. And that's it. So we just need to get this through testing, kind of just finish up development, and we're getting close, I think.
Very good. Thank you, Justin. That's a lot of work compressed into a few minutes.
Yep.
There've been quite a number of questions in the Slack, and so I'll read a couple to you. We do have one hand up. Flavio, I'm going to come back to you in a second after I read one, but you can have the next question. So one question is from Tan at Utrecht. How's performance when handling lots of small files? Have we done any testing around that yet?
We did do that last time. I can run those. I've definitely tested small files, but not necessarily performance testing on a lot of them. So I'll have to get back to Ton on that.
Sure. And yeah, of course, this is still a work in progress. It's not yet met the enemy. We have a question around, what is the default S3 circular buffer size right now?
What is it? I have it set to 5 at the moment. So again, that's in blocks, not bytes.
That's correct.
Right.
Okay, so 5.
And we did some performance testing, and we believe if we could get a S3 backend, we were testing on Ceph, presented it as S3, and that was when it was a lot faster than our local disks. And we want to run that test again. We were not able to do that yet, but we will try to get in that scenario, what the optimum number of entries in the circular buffer are.
Right.
I didn't see a whole lot of difference when I was testing it, just back, with the SSD,
Mhm.
writing to the SSD.
I know we've talked about internally having some reporting back about the statistics of how often that buffer is full, and then maybe even making it dynamically change depending on how those stats are handled. But that's a future bit of work, I think. Stefan from Surf would be interested in doing some performance test against OpenStack Swift with an S3 endpoint as well. So
Okay.
Stefan will probably put you in the loop here once we get this code ready for other people to see it.
Right.
Flavio, are
As soon
you?
as I feel comfortable with sharing it and having people use it, then
Of course.
we will
Your
do
name's
that.
already on it, Justin, so we want to make it good. Flavio, can you unmute? You can ask a question.
No, sorry, it's my fault. No question. Thank you.
Oh, he faked us out. Very good. Let's see. So, Kaivan, I think you asked if this was the right link. You pointed to the S3 plugin. So the answer is yes, it's the right place, but this is not yet released. This code is still being produced and tested. Paul Van Schaik says the current cashless implementation is not as fun when regularly dealing with 300 gigabyte files. So yes, this should be much better, and no more 300 gig cache files on your machine. I think Jason pointed out that the download right now has not implemented the in-memory buffering. Is that true, Justin?
That is true, yes.
Okay, so that's another bit of work that we still have to, maybe that was on your last slide. Another question.
Yeah, like right now the download is just synchronous, so it gets streamed and put directly into the buffer that is returned to iRODS.
Right. A question about on the policy level, is it able to disable, can we on a policy level disable random access like fopen, fread, fseek on a resource?
Yeah, you should be able to do that looking at the open flags.
Okay.
I don't know exactly right now how to do it, but I've done things like that before, so I see no reason why you couldn't do that.
Okay. We have a question from Robert King. It says, is the S3 protocol handling chunk size, or are you controlling how the input chunks are sent?
I am not doing that at the moment. I could look. I'm using libs3 the same way that the archive version, the old version of the S3 plugin is using it. If that is a setting that I can set and look at, I will do so.
Okay.
Now the part size, which I assume is different than the chunk size. We're talking about network setting there.
I am not sure the difference.
Okay, so the part size is just all dependent upon how iRODS breaks up the file. So iRODS typically uses 16 threads, and it breaks it up into 16 different parts and sends them in little chunks to the plugin.
Okay. Let's see, another question. Casper, I think he's at Aptiv, asks, we would be very interested too. Have you been trying any bulk continues transfer, like 10,000 files of random sizes for a few hours? How does that behave?
I haven't.
Okay.
That'd be a good thing.
We should make a list of things we haven't done yet, as these are interesting use cases. And these are, of course, going to be in Slack, and we can go back and mine them later.
Right.
Any other questions? Anybody want to raise their hand? We've got a few more minutes here. I think I've answered. I think I've asked all the things that are. Oh, Paul again from Mostrak is asking the time. So the number of threads is times the number of iPuts that are running, and I'm assuming that's the answer is yes.
That is true. That is, like, I believe in the slides it says per agent. So yes.
Okay, so an iPut.
But it doesn't, if you had 1 million people or 1,000 people, you could still exhaust your memory.
Right.
But I'm sure that could happen anyway, right? So,
right.
Yeah.
And that error would come from the operating system, not from the plugin itself.
Right.
It would bubble it up, yeah. Let's see, we have Mike Conway says, do we have similar thing cooking for GCP, meaning Google's cloud storage stuff.
Not at the moment.
I believe that's what Mike's asking for. But the idea is that it's the same idea, we would just different protocol.
Yeah. So yeah, the idea was we were going to take some of this code and migrate it to other object stores.
Right. As well, the conversation around this being the first step and kind of the first prototype and the proof of concept for the one true way to move data, right? So
Right.
Justin has wrapped, these DStream facilities that Corey talked about earlier. And once we know how to hold these correctly and kind of work out the bugs in the different layers of the libraries, these are the kinds of things that we'll do for all the target storage areas. So different technologies, both Unix file system as well as other protocols, I think. And one more question. For now, only iPut and iGet would work. Have you been thinking about something similar to AWS S3 Sync? In the sense that, oh, I see. So the AWS command line tool has a sync function, a sync operation.
Okay.
And I believe that iRSync would do the same thing here. Is that correct, Justin? I mean, it should trigger the same data movement, right?
It would. There's not a sync operation in the resource plugins.
Right.
That's what you're asking. So.
Well, but the sync, I think, just ends up calling, gets and puts anyway.
Yeah.
So, the sync is more of an orchestrator capability around the movement of data. And so like Alan was talking about, in the end, everything is just open a replica, write a replica, close a replica.
Okay.
And so this should be the first prototype of getting everything to be that way.
Right. And one thing I didn't mention is that pretty much all the data transfer is done through the transport DStream objects. But some other operations, S3 operations, like copy and read directory and things like that are done directly by the plugin because they don't have the context of those operations don't match with a streaming object.
We have one more hand up. I think Johannes wanted to ask something maybe?
Yes, I wanted to ask about iRAG because I lately just had the problem when I wanted to iRAG a whole bucket. It was not working, but objects inside the bucket were accessible. So kind of subfolders or logical structures beyond bucket level was possible, but to register a whole bucket, it was giving an error message. And might it possible that this is due to the plugin that there's a difference between objects and the whole bucket also?
So the question's about register.
Yeah.
And
Yes.
Well, right now, like I said, the read directory is not implemented yet. So in this new plugin, the register, like a recursive register, would not work yet, but it will. I'm not sure what the error you were getting was. The older plugin should have worked doing a recursive register of a whole bucket. We've done that, but we'd have to look into that more.
all right. Thank you, Johannes. I believe we are out of time. Justin, anything else? I think we're good. Thank you so much.
All right, thank you.